All right, we're going to go over two problems that would be on the midterm. It would be under one, credited as one full problem, but it'd be two parts to it, which have no relation to each other. So one is the approximate frame due to gravity loading. And so what does that look like? Is, okay. Okay. And what we're saying is that the connection here at the two ends are fixed. So I'm just going to draw that like that to show that it's fixed and it's not pinned. And what you have is that you have a distributed load being applied. And let's say that that's 100 pounds per foot. And so one of the things that we know is the inflection point when it comes to frame as an approximate method is 10% of the span of the beam. Let's just say it's 30-foot span. Let's draw like a point like this and a point like this, and let's say that it's 3 feet. So we pretty much have what we see in red is that distance is going to be 30 feet minus 10% times 10%, which is 6, is equal to 24 feet in width. So we know that the distance, sorry, 24 feet. So all we care is that when we're trying to find the moment is just find what the reaction is. So if we know it's 100 pounds per foot, we know it's going to be that the reaction is equal to WL over 2. W is 100, L is 24, and 2, that's equal to 2400 over 2, which is equal to 1200 pounds of reaction. And so now what we're going to be focused on is this part right here, right? We're going to draw it. And so what does it look like? It's like that. Okay, we know that that's essentially a fixed connection. We know that that distance is 3 inches. The load of the reaction that we have, 1200. And we have a distributed load of 100 pounds per foot. So what is a moment? We know that the moment is going to be, moment is equal to 1200 times 3 feet. And then we have, remember, the resultant, right, which is equal to, R is equal to 300, times the distance of 1.5, plus 300 times 1.5. $3,600, 1. So your total moment is equal to 4050 pound feet. So the approximate moment would be 4,050 pound feet right at that point. So it would look kind of like that. And this amount is 4050 pound feet. All right. That's the first one. Here's the other one. 2 parts. as discussed. Okay, so this problem was taken from another professor in terms of this graph. It's an influence line. So we're going to talk about influence lines and what that means, okay? So an influence line is pretty much what is reaction at a certain point based on a load being applied. So really all we have to do is that what is the reaction if we say that the load right here is, say, 5 pounds, right? Well, load at 4, let's just say it's 5. The location of load is 5, so really you'll take 5 times 1, so therefore your reaction is 5 pounds. Okay, what if it was applied over here? Well, it's going to be 5 pounds here. It's going to be 5 times 0.5, which is 2.5 pounds. Right? What if you had 3 loads applied? What would be the reaction at the point? So it's going to be 5 pounds because it's going to be 5 times 1 plus 5 times 1 plus 5 times 0.5, which is 2.5, so you have 12.5 as the reaction at that point, right? Now, if you have a distributed load, along this area, then, and let's just say that's 5 pounds per square foot or something, or pounds per linear foot. All you're doing is you're just taking the area to find out what the reaction is. So it's just going to be the area times the 5 pounds per linear foot. So what is that? Well, we've got a rectangle here. So that is 10 times 1 is 10 times 5 is equal to 50. And right here we have half of it of that, which is really going to be 10 times 1 times 0.5 times 5, which is equal to 25. So total is going to be 75 pounds.